The Great Pyramid of Giza, an iconic structure that has captivated the world for centuries, this monumental achievement of engineering and mathematics stands as a testament to the ingenuity and skill of the ancient Egyptians. The pyramid's precise alignment with the cardinal points of the compass and its internal chambers and passages have sparked both awe and wonder. But have you ever pondered how exactly this architectural marvel was constructed without the aid of modern technology? Join us as we delve into the fascinating theories and evidence surrounding how the Great Pyramid was really built. We all know that pyramids were built thousands of years ago by the ancient Egyptians. But if you think about it, this is still quite mysterious, since there are many things that we do not know about the past. Even something as basic as how they constructed these gigantic pyramids is still a mystery. According to historians, the construction of the Great Pyramids took around 20 to 30 years. However, how did they transport such massive stones to the site? These stones are so heavy that even today it is difficult to move them. Let alone thousands of years ago. They used copper tools in those days. So how did they manage to cut through these stones? There are a lot of questions like this, and today we will try to answer them. There are several theories about how the pyramids were built, but today we will focus on one particular theory. The corridor theory is one of the more popular theories about how the pyramids were built. The main premise of this theory is that the ancient Egyptians created a ramp system that allowed them to transport huge blocks of stone up the pyramid. To support this theory, researchers discovered a series of corridors inside the Great Pyramid. These corridors are passageways that were most likely used to transport workers and building materials to different levels of the pyramid. What makes this theory plausible is that these corridors are perfectly aligned with the exterior faces of the pyramid, suggesting they played a crucial role in its construction. One of the most significant pieces of evidence supporting the corridor theory is the discovery of a shaft near the king's chamber. This shaft, approximately 10 meters deep, was found using non-invasive techniques such as ground-penetrating radar and magnetic resonance. While the purpose of this shaft remains uncertain, it has been speculated that it may have been used to transport the massive granite blocks that form the pyramid's inner sanctum. Granite, known for its durability and resistance to erosion, is a highly dense material. In fact, the average density of granite is between 2.5 and 2.75 grams per cubic centimeter, making it considerably denser than the limestone or tura blocks that constitute the majority of the pyramid's structure. Given the immense weight of these granite blocks, it is reasonable to assume that moving them would have required a sophisticated system of ramps and passages, aligning with the corridor theory. While some skeptics have challenged the interpretation of these features as corridors, the evidence strongly suggests their functional significance. For instance, the corridors exhibit signs of wear and tear consistent with the movement of people and objects. Additionally, some corridors feature protruding stones known as pigeonholes, which served as temporary supports during construction, further reinforcing their role in material transportation. A team of researchers led by Bob Balvalk, a Canadian engineer, conducted a study to test the feasibility of this ramp system. Their findings, published in the journal Antiquity, provided compelling evidence that supported the corridor theory. Balk's team proposed that the Egyptians utilized a double ramp system, one outside the pyramid and another along its interior. The outer ramp would have facilitated the initial movement of limestone blocks from the construction site to the base of the pyramid. From there, an internal ramp would have transported the blocks to higher levels. This system would have eliminated the need to drag the blocks horizontally across the pyramid's surface, reducing the labor-intensive aspects of the construction process. Their research revealed that the angle of the internal ramp could have been as gentle as 7 degrees, making it easier to haul the stones to the top of the pyramid. Moreover, Bulk's team discovered that the outer ramp could have been dismantled once the internal ramp was in place, optimizing the use of resources and minimizing waste. Their conclusion that the ramp system was entirely feasible with the technology and manpower available at the time. The researchers estimated that each block would have traveled approximately 850 meters along the ramp, requiring only about 12 minutes of effort to raise a single block to the top of the pyramid. This finding challenges previous assumptions that the transportation of blocks was achieved through brute force and over a much longer time frame. In fact, the estimated timeline for the construction of the Great Pyramid, ranging from 20 to 30 years, might be too long, considering the efficiency of the ramp system. Bulk and his colleagues suggest that the pyramid could have been built in just 5 years, which would have required an average of 1,300 workers. This estimate aligns with historical records, indicating that a large workforce was indeed employed during the pyramid's construction. The ramp theory is not without its critics. Some experts argue that the evidence for its existence is circumstantial and that the corridors could have served other purposes, such as ventilation or as part of the pyramid's internal structure. However, the discovery of the previously mentioned shaft near the king's chamber provides a strong link to the theory. As researchers continue to explore the pyramid's interior, they may uncover additional evidence that sheds light on how the ramp system functioned. Other experts have raised concerns about the feasibility of the ramp system, suggesting that it would have been too steep or unstable to support the weight of the blocks. However, Bulk's research indicates that with proper engineering, the ramp could have been safely constructed and maintained throughout the building process. Further studies can help us understand the logistics and manpower involved in building the pyramids. It is important to consider alternative theories, while the ramp theory offers a compelling explanation for how the pyramids were built. Other theories propose different methods of construction. For example, some researchers believe that the Egyptians used a combination of ramps, levers, and rollers to move the blocks into place. Each theory has its strengths and weaknesses, and none have been definitively proven. It is possible that a combination of methods was used, utilizing the available resources and technology of the time. While the Great Pyramid of Giza continues to captivate our imagination, the methods used to build this ancient wonder remain shrouded in mystery. However, thanks to ongoing research and technological advancements, we may one day soon uncover the secrets behind its construction. Whether it was through the use of ramps, levers, or a combination of methods, the ingenuity and skill of the ancient Egyptians are truly remarkable. As we continue to explore the pyramids, we can appreciate the legacy of these ancient builders and the timeless wonders they left behind. What do you think about the corridor theory? Let us know your thoughts. If you enjoyed this video, please give it a thumbs up and share it with others who might find it interesting. Don't forget to subscribe to our channel for more informative content. Thanks for watching. Until next time, keep exploring the world around you and never stop asking questions.